of equations using matrices. So think back to section 8.1. We took systems, we wrote them as augmented matrices, and then by hand we could put it in row echelon form and then solve by back substitution. In the calculator, it was really easy to put it in reduced row echelon form, and then we know exactly what each unknown is. Okay, so that's one way to solve a system. Then in 8.3, we introduced the inverse matrix, and we were able to write matrix equations like the coefficient matrix times the variable matrix equals our constant matrix. And to get the variable matrix all by itself, we would multiply both sides by the inverse. So essentially your variable matrix is always your inverse matrix times your constant matrix. And you practiced that on the stations you went around to yesterday, right? Real important just that you make the connection. Inverse times constants matrix. So now here's the third one, Cramer's rule. We're going to use determinants. So we're going to let D, big capital D, be the determinant of the coefficient matrix. Okay, so we saw coefficient matrix back in matrix equations and inverses. It's just the numbers, so it'll be a square matrix that are in front of your unknowns. Okay, we're also going to have like D sub x, which is another determinant of the coefficient matrix, but we're going to take the x column of the coefficient matrix, because that's what we're trying to solve for when we use D sub x, and we're going to replace it with the constants. The other columns in the coefficient matrix, the y column and the z column in D sub x, will be the original y and z column. So you just like take out all the x's and you put in the constants. Okay. So I don't have this written, but depending on how many unknowns you have in Cramer's rule, you'll also need to find the other matrices similar to that. So like if you need to solve for a y, you're going to need a D sub y matrix. And D sub y matrix would be the determinant of the coefficient matrix, where the y column is replaced with constants. And this could keep going, right? If it's a 3-variable system, you would need the same thing, the coefficient matrix, but then go in and change the z column. I suppose if it was a 4-variable system, like it had x, y, z, and w, then you would have to have a fourth one, d sub w. At that point, you'd have 4x4 coefficient matrix, so you would need your calculator for that. Okay, but you could copy the same thing down, it's just the z column is replaced. So for whatever variable you're trying to solve for, you're going to replace that column in the coefficient matrix with the constant column, and then you just do a new determinant. Okay. So then you have all these determinants. You have the determinant of the original coefficient matrix, then you got the determinants where you replace the columns, and these are your solutions. X is the determinant with the x column replaced, divided by the original determinant. Y is the determinant with the y column replaced, divided by the original determinant. So on and so on. So Z is the determinant with the z column replaced, divided by the original determinant of the coefficient matrix. So like think about determinants from what we know from Wednesday. They're just numbers, right? So we're taking a number divided by another number, and that's our answer. Okay, so we're going to do 2 examples. Okay, first one will be pretty quick because it's 2 by 2, 2 variables, so those determinants don't take long, and then we'll maybe split the work for the 3 by 3. Okay, we'll do some group crowdsourcing here. Okay, let's solve the system. Well, let's find D. D is the determinant of the coefficient matrix only, so 3, 4, 5, 3. Difference of the product of my diagonals, so I get 9 minus 20, and my determinant is negative 11 for the coefficient matrix. Okay. I'm going to have to solve for two unknowns, an x and a y. So I'm going to need two more determinants, d sub x and d sub y. If there was an x, y, z like the next one, I'm going to need three more. And what I'm going to do for those determinants is if I'm solving for x, this 3 and 5, we're going to replace with the constants 1 and 9. So this column changes. The x column is now 1, 9. But the y column stays the same. So it's 4, 3. So it is the coefficient matrix, but I've kicked out the x's and I put in the constants 1 and 9. Do your determinant there. That's 3 minus, what is that, 36? So that's negative 33. And I can now solve for x. X is negative 33 divided by negative 11, so 3. Pretty easy. Repeat the process for y. So I would go back to like my original determinant matrix. Now I'm going to replace the 4 and the 3 with the constants 1 and 9. So I'll put those in for my y column. The x column goes back to what it was originally in the coefficient matrix, 3 and 5. Okay, so you see you're only changing one column at a time in the matrix with the constants. You're replacing whatever variable you're trying to solve for. So now we're going to try to solve for y. So we replace the y column with 1 and 9. And what do I get? 27 minus 5. So 22. And y is the determinant with the y column replaced divided by the original determinant of the coefficient matrix, so negative 2. Because this is a linear system, the answer should look like an ordered pair or an ordered triple. It's a point of intersection. So I would say 3, negative 2. Okay, not too bad, right? Okay, so we will do the 3 by 3. Let's all do, just kind of as a review, the coefficient matrix together, and then I'll split your pods up, and I'll have you guys do like the d sub x, d sub y, d sub z, so that you don't have to do. We won't do 4 3 by 3 determinants. Okay, so I'm going to do d. That's just my regular coefficient matrix. Now, of course, be really, really careful. Make sure you're copying down your coefficients with the correct signs. Okay, my x column will be 4, 2, 5. My y column is negative 1, 2, negative 2. And my z column is 1, 3, 6. Copy my first two columns. And start my determinant. So this will be 8 times 6 is 48. Let's see, minus 15, so I'm down to 33. And then minus 4, so that's a 29. Multiplying on the diagonals, and then I add up all the products. And then 5 times 2 times 1 is 10. This will be negative 2 times 3 is negative 6 times 4, so that's minus 24, so I'm down to negative 14. And then minus 12. So negative 14 minus 12 more would be negative 26. And that means I'm really adding 29 and 26, so what is that, 55? Okay, I'm going to split our work, so I'm going to have this group, and Ashlyn and Garrett, you guys do d sub x. I'm gonna have these two. You guys do d sub y's, and then these two pods you do d sub z's. Okay, so kind of like work it out. Maybe check in with your pod members, like what you're getting for the product of your diagonals, right? We should all be able to calculate 3 by 3 determinants. And like I said, some of the numbers, because look at your constants, 12, 1, 22, some of the numbers get kind of big, so if you want to use the calculator to do the products, that's fine. You subtract these two. Good clarifying question. I think this cross concern. Did you guys agree on a number? Yes, we did. Okay, so I'm going to do a little bit of crowdsourcing. I did on the board put up my setup for each of those. So notice I just wrote in red that constant matrix, and you just see the constant matrix. We move it through the different columns because first we're replacing the x's, then we're replacing the y's, then we're replacing the z's. So my d sub x people, what did you guys get for your determinant? 110. So then x is 110 divided by 55, which is 2. Okay, d sub y's, what did you guys get for your number? Negative 165 for the determinant. And then y equals negative 165 divided by 55, which is negative 3. Excellent. And then d sub z's, what did you get for your determinant there? 55. and z equals 55 over 55. So then my order triple would be 2, -3, and 1. You know, if you have extra time, which a lot of people I think will on the matrix exam, whenever you're solving one of the systems, you can always see if you've actually got the accurate answer by taking 2, -3, 1 and plugging it into any one of the equations at the top. Like, it should work for all three. So, you know, this would be like 10 plus 6 plus 6. Yeah, that is 22. 10 plus 12. Okay, so it works in that third equation, and then it would work in the other equations as well. Like I said, this would be no calculator. So, like, obviously, the 3x3, I really love Cramer's rule because I just think determinants are fun to do. They're just, like, so easy, and it's just, like, calculate. So I really love Cramer's rule, but I would say, like, when you are doing the 3x3 by hand without a calculator, it does get a little tedious because you have to do 4 determinants just to get to your answer. So for 3x3s, if I was doing it no calculator, I guess I kind of prefer row echelon form for me personally, but I also sometimes like hate row echelon form. So then I'd rather just do the determinants, even though it'll take me a while. On the quiz tomorrow, some of the questions will say like solve this system using matrix equation. So then you have to show me that you can do it with the inverse. Or it might say, solve this equation using Cramer's rule. Then you have to show me that you can do the determinant part. But as you prepare for the test that happens next Wednesday, I know on the test it always gives you an option. So like if there was a 3-variable system on the test that was no calculator, your 2 options would be augmented matrix and Cramer's rule. I wouldn't give you the option of a matrix equation for a 3-variable system because you don't know how to do an inverse without a calculator. So then you would have to choose, like, do I want to do the row echelon form or do I want to do all the determinants? Well, parts of the test, the majority of the test is no calculator. Because obviously you could just type everything into the calculator and get your answers. And I want to make sure that you understand how matrices work. So. But there is like a small portion of the test that is calculator. Okay. So you have homework assignment. Just like 7 problems, Cramer's rule, pretty reasonable. And if you're working on it today in class, you can do like we did, a little bit of crowdsourcing and split the work. That would be fine with me. If you do like a few of the 3x3 determinants, but maybe you practice a few 3x3 determinants in the calculator, that's not going to bother me. But I do expect you to be able to calculate 3x3 determinants on your own. And you also have that matrix worksheet, and I've got my answer key up here. I will post my answer key later today, but if you want to check any of your answers that you've been working on, you can. And I'll check both of those assignments tomorrow. Yes, sir.
The quiz is sections 3